Thank you very much for the introduction and the invitation. I'm going to be talking about empowering artists through machine learning, and the talk will be how we can balance creativity and control. And this is going to be basically a how-to guide in research in the industry. I'm Miladi, and this is my social. Please feel free to stay in contact. Before my job at Cinesite, I was a researcher at DNEG and Embark Studios working on ML-based animation. And before that, I was an artist, and I come from an artist background. I studied VFX in university, and from then I moved to machine learning. Cinesite is a group of studios that offers visual effects and animation and visualization for different 3D media, but particularly films and animation. And we have studios around the world, as you can see. Here's some of the recent productions that we've been working on at Cinesite, some of which you might be familiar. And let's have a quick look at the reels from the past 30 years of Cinesite.
I've known you a long time. It was a long time ago.
Come on, let's boogie.
You're a wizard, Harry.
Welcome to Hogwarts.
Sort of exciting, isn't it? Breaking news.
Thanks, Mike. I'll probably quote you on that.
Name's Bond. James Bond.
It's the best we have.
We should get moving.
Florals! I want a home. I want our children to grow up in peace.
Mrs. Potter, what's that?
Thank you for watching that. So let's talk about ML at Cinesite, which is my area. ML is very new at Cinesite. We just started with me joining about 6 months ago. We've been basically setting up our infrastructure and setting up research as we've been going along, and we've been learning a lot. And I wanted to share some of our learnings and the pillars that we've been using with our projects here with you. So far, we've worked on a few different projects: rig approximation, retrieving information from our database of documentations using LLMs, and most recently, ML-based lip sync. And some of the pillars are that we don't use ethically questionable data sources. Most of us are artists at Cinesite. We feel very strongly about this. A lot of works are infringing on artists' rights, and that's really important for us, and we don't want to infringe on their rights. And we also really care about leaving the creative control completely to the artists. That's what they are there for, and I think it's kind of meaningless to give that creative control to machine learning models. And we also want to involve artists in every step of the way. This is going to be tools that are for them, and I think it's really important to get their feedback and ideas at every step. And finally, we want the output should be easily and fully editable. I'll go into why exactly is that a bit later, but I hope if there's one thing you take away from this talk is that please listen to artists, and the rest of the talk is basically about why is that. I think it might be helpful to get a bit of a background on large-scale 3D production. I'm sure a lot of you are very familiar with how games and films and animations are made, but for those of you who are not as familiar, I think it might be helpful to have a look at this. And I'm focusing on large-scale production, particularly because only large companies can afford ML research. Typically, in the 3D process, we start from concept that some artists put together some references, and that creates the look of the character or the assets. From there, it gets modeled, and then rigging TD would make a digital skeleton of that and get animated by an animator that puppets that digital skeleton to brings it to life. We also have lots of different roles in the VFX and 3D pipelines, including rotoscoping, lighting, creature TD, match moving, texture, FX, and all of these are very specialized fields, and there are people like that spend their whole life trying to master these.
Can we give them some of these lights? Because your slides look beautiful, but they're almost invisible under this light.
All right, I'm sorry, I don't know how to do that. Right, sorry. And it's basically a very long process of like tediously designing every aspect of and every detail that we go and see on the screen. And there's a lot of back and forth between all of these stages. And as you can imagine, that makes a very challenging work environment for artists. And like, here's are some of the things that is typically needed from artists in the industry. There is lots and lots of revisions and feedback. In VFX, we have specifically something called dailies that we might sit in a room like this and everyone shows their work and it gets judged pixel by lots of people. And it's very intimidating, as you can imagine, but often like one single asset can go through hundreds of iterations before it's approved. And that's very challenging. And anything can change at any time. We have can be decisions from the higher-ups. For example, like you could be working on a superhero film and very last minute, few weeks before that you're supposed to finish the VFX, suddenly the cape has changed and now you have to go back to every shot and change the cape everywhere, and that is very time-consuming. It's highly detailed creative work. There's an insane amount of detail that goes to every 3D asset that we see on the screen. For it to feel believable, we need to consider everything. Like artists even add like small details like fingerprints, scratches, dust, and all that stuff to make these work look realistic. And of course, they need to stay consistent to art direction. Every asset and every shot needs to be consistent within the world that we live in. And they use highly technical and specialized software that is constantly changing. And this is more true for games, that often you might be building the engine as you are working on it. And that's like the analogy that I quite like for this. Is kind of like riding a train and building the train tracks at the same time. And coordinating with thousands of people across different time zones and different companies is extremely challenging and is an area that hasn't been talked about enough. And let's have a look at this VFX breakdown from Witcher to give you an idea of the complexity we are dealing with. And adding to everything that I said, we also have tight deadlines that like you have to follow. Like, for example, the next Marvel movie is not going to get canceled because we don't have an asset ready. And there's incredible amount of detail. So you have muscle simulation, fat simulation, skin simulation. There's like lots of technical work and artistic work that goes into this. And as the worlds get larger, this gets much more challenging as you have larger number of assets and characters. So as researchers, developers, how can we help artists to make their life easier? How can we make this difficult task a little bit easier for them? Of course, I'm going to be looking at ML because that's my specialism. And I'm sure you've all heard of generative models. They've been recently making a lot of noise. And they've been making very impressive results in lots of different mediums. So now almost anybody can just type a few words and you get music, animation, films, pictures, paintings, like lots of different mediums is possible to have this. And like this is work that often could take weeks of many artists' work, and now we can have this, make this within few seconds. And a lot of the issues that these models have had has been resolved. Like they follow your prompt better, added new features, quality is getting better every day. So it seems like this should change the industry any day now, right? Why hasn't it? Like, why don't we see this being used more in production? There's a lot of reasons in my opinion, but I think some of the main reasons that it's not been used, mainly that, as I said, ethically and legally, this is a gray area using this large-scale data sets. We don't feel comfortable using them. Our clients often don't feel comfortable as well, because it's also not clear what is the legal implications of using this in your work. Will you be able to copyright your work if you've been infringing copyright for making that work? And I think, in my opinion, the most importantly, these models output final pixels, which are not an editable representation. Typically, artists work with 3D models and 3D geometry that are editable, but final pixels, like, you have to almost kind of like draw over them, render over them, and that is very challenging to fix. And often these models really don't have a mechanism for you to do highly specific edits with them, and you kind of have to wish for the best using, like, trying to describe your edits with words or in painting, and it's very challenging. And if you want to manually fix those issues, it can often take as much time as it would just starting it from scratch, because you're working with pixels and you have to work on top of them, so you kind of have to recreate the full shot again. And it's very difficult to get consistent results. Like, for example, like the hair of the character can't change at every shot. Like, these things need to be consistent. We have people whose entire jobs is to ensure this consistency for films, and we can't just completely lose that consistency when we get to the VFX stage. And the same can be said for art direction. Like, I'm not sure if you've seen like some AI short films that's been made. Every single shot looks like a completely different movie and has a completely different art direction, and that's just not something that we can use in production. And it completely changes existing workflow. Like, artists have been honing their skills for decades using existing softwares and frameworks, and now we're just asking them, use your words, be a poet. Like, that doesn't work. And they also can't interpret the feedback given. Like, for example, I can tell a human, this looks tacky, fix it. But if I tell that to an AI, that means absolutely nothing. And a lot of these issues that I've been mentioning is basically about lack of control over these models. So what is the right amount of control for creative work? To give you a background about what I mean, like back in the 70s when the first 3D object was made, the Utah teapot, they used to make these 3D objects by specifying every 3D coordinate of every point there. And that's extremely tedious. Even though you're getting full control over your creation, that is too much control. Like, you can't do creative work when you have to worry about every single point. Over time, 3D software made this much easier, and we get to the picture in the middle. That's ZBrush, and that looks a lot more like sculpting with a clay almost. There's still a lot of technical challenges to it, and it's still fairly technical, but as we can see from the results, taking some of that control away has helped people with their creativity. But as I said, like, this is still very time consuming, so I think there's still room for improvement. And on the other side of the spectrum, we've got the generative models that, as I've said, like, they just have almost no control in them. And this is like just wouldn't work in creative work. Like, for example, if you were to show this to an art director, there would be a million comments about it, like, where's all this invisible lights coming from? Why is the hands bending like that? And all these weird issues that just there is no mechanism for you to fix these. So and in my opinion, it's also really important, beside finding the right balance of control, it's also really important to provide that flexibility. Like, to give you an example, during pre-production, you might want to test lots of different ideas, lots of different styles, and you don't care so much about the details. You just want to test different ideas, and generative models can be great for that. But then during production, you want to go and polish those assets and focus on the exact look, and that's something we are missing right now. We can't move between these different control levels. So how can we add more control to these ML models? Lots of people have been working on this. There's been so many different ways that researchers and developers and artists have been trying to do this. UI and UX is a very important way. We have tools like Comfy UI that have proved extremely successful by just providing an interface for users to combine different models and try different things and share their workflows, we see much more interesting results from that. Another avenue is also training other models to guide the process. So think control nets, where you might give a skeleton or the depth of the scene as a conditioning for your generation process. And it's a very valid approach is also fine-tuning large pre-trained models. Like, for example, for the art direction aspect that I mentioned, if you fine-tune your pre-trained model on a specific art direction, you might get much more consistent results. Or you can also add new features to the models, as we've been seeing, like image in-painting, conditioning with another image, and all of these are very important control features that we can use with these models. And one of my favorite, we can condition these models using data generated from 3D software. So for example, you could go Blender, put a sketch of a building together, get the depth map from that, and then use that for stable diffusion, for example. And when you combine these approaches, the results can get pretty powerful. Here's a work from a user in Reddit that they mix all these different approaches. And as you can see, like, they pose the character in Blender, and from there they go to stable diffusion. Now we have almost exact control over the pose of the character, which is way more control than we had before. But there's still one big issue here. Like, we're working with fundamentally flawed technology. For example, if you had this in real production, they might tell you the clump of the hair doesn't look right, make it clump a bit more. Here, there is really no mechanism for you to do it, but in a typical pipeline, you just go to the hair generation system and just change a slider. As easy as that, but how do you do it with stable diffusion? Nobody knows. So now that we looked at some of the issues, how can we deploy ML in production? Or just generally, how can we do research within the industry? How can we solve this issue? And in short, it's pretty difficult. And let's get a better why it's so difficult from my personal journey with animation. Animation's been around as a craft for thousands of years. It's probably the oldest craft in the pipeline. And for the 2D animation, like, the first examples of it we have is the pot that you see on the left. And if you rotate it, you get an animation that looks like that. And this is from 5,000 years ago. And it hasn't changed all that much in that 5,000 years. Of course, we have virtual techniques that makes it a lot more convenient and faster, but it's the same essential idea of drawing 10 to 20 frames a second. Same can be said for 3D animation. It's quite similar to puppeteering, and if we look at more modern forms of puppeteering, like stop motion animation, it's pretty much exactly the same thing. And of course, again, we have the conveniences of the modern world. We can move around the scene very quickly. We don't have to worry about taking a photo every time we change the pose. But it's more or less the same very difficult and time-consuming process. My first experience with it was during university. I was very terrible at it. It was extremely difficult to make animations that had a good sense of timing and a good sense of physics, and they just always looked floaty and extremely weird. And it was really easy to spot these issues, even like for more seasoned animators. It's really easy to spot these issues, but it's really difficult to solve them. Of course, lots of people have been doing this, and they are much better than me, including people in my course that have made much better animations, and because they were more talented and they spent a lot more time doing it, but nevertheless, it's a very difficult craft. And if you look at this professional animating, this few seconds of animation, this video has been sped up by like 5 to 10 times. So this person basically spends about 5 to 10 hours animating that 2 seconds of animation. It's an extremely manual workflow, and this is even more exaggerated, like for VFX work, when we need everything to be photorealistic. So this 2-3 seconds of animation in a VFX pipeline might take about a month of someone's work. And if you can think of a movie or a TV show that has hours of content, many characters in each scene, you end up with hours of animation data that might take years to create. And like, this just doesn't scale, and like that can be even more true for games, that you have to have a interactive animation for any scenario, and a lot of the times people just cheat their way out of it and the animations can not look so great. So how can we help this using ML? How can we make this workflow a bit easier? This brings me to Embark. This is my first experience with ML and animation. We were making physics-based animation using machine learning and reinforcement learning. For this use case, we wanted our users to create any characters they wanted without any restriction, and they should be able to interact with any words that also users create. And if we were to do that manually, that would just not be feasible. Like, users might create thousands of creatures every day. And we wanted our approach to be fast and automatic, but also agnostic to the type of animation. So here we had flying creatures using a approximation of aerodynamic physics. And there is no animation data here at all. They basically learn to move around the world by just, we tell them, you need to get to this point, and that's all they know. They have never seen any creature walk. But they look somewhat plausible, like something that could maybe exist in the world. And how is that? And that's basically because of laws of the physics. Since these creatures follow the laws of physics like we do, they feel kind of real. And you feel really bad when you throw boxes at them to try to stress test them. And yeah, the way we basically achieved this was we created these robots. These are all robots in a physics simulation, and we use reinforcement learning to teach them how to walk. There was another parallel project that I was less involved in. The goal of this project was to see if we used a game workflow of iterating lots of times on the animation, can we get better quality? The short answer was yes. With iterating on the animation, as you would typically do, we were getting much better animations. This is supposed to be a building-sized robot, by the way. That's why it's so slow. And they were very adaptive. So you could throw them around, you could throw things at them, and they would react very naturally to it without ever having to be trained for them or seen any animation of it. And that was really great for us. We got a lot of dynamism. But after some time, it became very clear that this is not the best way for animators to work. The reason for that was to iterate on the animation. They had to change the physical design of the robot or change the reward that we were getting them. And as you can imagine, artists are not robot designers, and that's very difficult for them to do. And it's kind of like the text to image if you think about it. So you have control over what's happening, but this control is so abstract and so far from what you're getting and so indirect that it becomes extremely difficult to work with it. And for our case, this was sort of fine. We cared so much about the unpredictability and the physical interaction that we were willing to live with this. But as you can imagine, this would be completely unacceptable for most other games. After Embark, I moved on to DNEG, and I was also working on ML-based animation there, but this time from a different perspective. Instead of using physics, we were using a lot of existing data. For human motion, we have hours and hours of mocap data in lots of studios. So why not use that? Instead of having to rely on physics, we can use generative models. And because we wanted to focus on artists this time around, we needed to bake in some sort of mechanisms for the artist to get exact control over this. This is a work by Unity. I'm not allowed to share what we did at DNEG, but this is the closest example I could find to it. And we built this system that we called Neural IK, that essentially it would change the rest of the body by just changing some control points. So now it adjusts the full body instead of just adjusting every bone one by one. And now by just moving the gaze direction, we get very natural movements for the full body. And that makes animation, in our experience, about 5 times faster, which is a very big gain for us. And the great thing about it is we still get full control over the animation. We're working with 3D data. So you're not happy with what you're getting, just switch back to normal mode and you can edit it exactly like you would do any other time. From there, we moved on to crowds. And this was a similar problem, but this kind of showed like why you need different levels of control for different tasks. So for crowds, the goal is to have thousands of creatures and thousands of humans potentially walk, and animating every one of them handy by manually is very difficult and just practically impossible. So like what typically artists do is they control them using like simulations or draw a path on the ground, and they just loop the animation constantly, and they just like kind of bend them to follow the path. And as you can see, this doesn't look great, especially if you get a bit close. It looks very repetitive and very obvious that this is computer made. So how can we improve this workflow using machine learning? Like, of course, I don't want to edit joint by joint, so how can I use the existing workflows of drawing paths and using particle simulation, but generate these high quality animations on the fly using machine learning? Turns out there's been lots of amazing work already done in this area. The paper that we were most interested in was Deepfakes by Sebastian Stark. He's an amazing researcher and he has a lot of work in this area that I highly recommend you to check out. And these models basically gave us very different levels of control. So for this, we were using paths and we were getting fairly realistic animations following the path, but of course, this wouldn't be useful for an animator, but it was exactly what the crowd artist needed, and this really highlighted how you might need different levels of control for different tasks. But what's interesting about it, we were using the same exact data, very similar architecture, by just changing how we interact with the model and changing the inputs and outputs, we were getting very different levels of control from it. And because we are again working with 3D data, in theory, you could generate thousands of animations using these models and then go use the other models and like if you want to specifically change any one animation. So this brings me to Cinesite. This journey has had some takeaways for me that how to do research in the industry, and I hope that I found it very helpful for my work at Cinesite. Hope that it also helps your research as well. Firstly, cool demos are great, but just don't underestimate how much work it is to implement them in production. To me, Stable Diffusion and most research papers are cool demos. To give you an example, like deepfake has been an area that we've been seeing work in for many, many years. And if you were to believe the papers, they've been looking photorealistic for also many years. But if you were to implement deepfake for production today, you would realize there is so many issues that it just hasn't been considered. You have different kinds of cameras, different lenses, different focal lengths, different distances to that. You have occlusion, motion blur, different angles, all these problems that just basically make it extremely difficult to implement this in production, even if it's a very mature field like deepfakes. And editability is absolutely non-negotiable. For almost every task, there are some tasks like in production that you might be able to get away with it, but for most tasks, it's really not negotiable. And consistency and predictability are completely necessary. If you think about it, if you can't predict what your tool is going to do, you're not able to master that tool and like hone your craft. Like it's kind of, if you think about it, it's kind of like a carpenter using a hammer that every time you use it, it does a random thing or puts a random amount of force. Good luck building anything with that. And finding the right balance between creativity and control is crucial. And I think, in my opinion, even more important is to provide that flexibility. Like at least if you provide that flexibility to move between different levels of controls, then the artist can decide how to use it, when to use it, and they're very creative. They will find a use for it. And domain knowledge is extremely underrated. Like I cannot recommend you enough to learn as much as you possibly can about the domain you are researching in. There's been so many times in my careers that there's been issues that we've been trying to solve with like so many complex algorithms and models, and turns out there's a much better solution for it from 20, 30 years ago that's much faster and much simpler. Don't reinvent the wheel and waste your time. And as much as possible, try to get constant feedbacks from your users and artists. they are the ones going to be using the tool at the end of the day. If it doesn't work for them, it just doesn't work. And lastly, but most importantly, please listen to artists. Thank you very much.
That was very interesting. We have plenty of time for questions.
Thank you. That was a really fascinating talk. I really enjoyed that. On a similar note, I was really interested to know if you could share more about the animator for the walking with the creatures, so that they would figure out the different ways the creatures would walk. Like, is there anything else you can talk about it? Like, how long did it take to run? What kind of reinforcement learning did you use? Anything like that?
Yeah, sure. So sorry if I babble a little bit about this. Please ignore it if it doesn't make sense. But we were using off-policy reinforcement learning. Specifically, we were using SAC for this, soft actor critic. And we were using lots of different methods to make this work. As you can imagine, they might have to work on ice fields. They might have to walk on hills, and they can't start walking just on a hill. It's kind of asking a toddler to learn how to walk on a Mount Everest. It's just unrealistic. So we used lots of other techniques to make them work in a more open-ended manner. So we used curriculum learning. So we would start with simpler environments and slowly increase the complexity, sort of how you would learn in school. You don't start learning integrating first day of school. You start addition and so on, and you build on the previous knowledge. And that's exactly what we wanted to do with them. And yeah, I'm not sure how much more I can share with that, but yeah, maybe after this we can talk.
Thank you.
Great talk. I'm sure there's loads of questions I could ask you, but specifically interested in when you're working at the cutting edge of things, and there's lots of research things you could propose as we could build this tool and it will save us loads of time, or let me grab this person, this person, this person, and let's form a group, and we'll that's a lot of time to put into something, and it's often a hard sell. So what's your experience with dealing with that, rather than I guess we're just gonna have to leave this tool for now because we can't dedicate time to it? Or
yeah, it can be pretty challenging. It's you have to kind of find the right audience for it. I kind of like to tailor the pitch to the person. So for the artist, talk about exactly how they would interact. But for if you're talking to the higher ups, just talk about savings and money, and that will work. But yeah, it's challenging. Companies don't usually want to spend a lot of money on open-ended research that might not work. I think it's what helps the most, building a case that this exists in the literature. I'm fairly confident that it could work, and then just try to build up a case that, as certain as it is, the better it is. Unfortunately, companies don't really want to take a lot of risk.
what else?
Thank you. Thanks for a really fascinating talk. There's work around self-supervised learning, where you maybe generate an image, then from that image you work back to a model, and then from that model produce the image again, and then you know whether your model's any good, and then from that you can then work with that model. I mean, have you looked into that sort of thing for I've seen it done with, people in my university are doing that with still images. Have you looked at that for dynamic animations?
Yeah, to some extent. We used contrastive learning for the vision side of those creatures. So we were giving them a height map of the environment, and to give enough detail, that can be quite large. So we needed to learn a better representation of that image, basically. And there's no supervised signal there exists. So we used contrastive learning for that. So we would basically augment the images in different ways, and then the training task would become, is this the same image just with different augmentation, or is this an entirely different image? And from that, they managed to learn a much more useful representation.
Okay, great, thank you.
Interesting, really fascinating talk. Where do you find artists are actually using Gen AI in Cinesite?
Don't really that much. Like it's mostly in pre-production if it's used anywhere. Like one of the only and like quite creative like uses I've seen from it is a visual effects supervisor. Like they're thinking of a location for a shoot, so they might go on Google Map, take some photos, and then they might use stable diffusion to like, I'll make the signs look like from the 60s or something to just kind of get a quick visualization. But that's the only use I've actually seen being used.
So really just at that ideation stage.
Yeah, exactly, ideation or like visualization. And also, I guess it's a bit of a gray area. What do you exactly consider generative models? Like technically, like that animation model is a generative model. So yeah, it's like, but yeah, we don't really use like large scale internet data sets for these.
Actually, so again, great talk. So how much is this being pushed by the continued desire for additional kind of realism and complexity? And kind of how does that, how much is it driving our kind of innate ambition for everything to become more and more real and more complex rather than looking at it from an aesthetic point of view? And another question is kind of, where do you sit with this idea of it being a democratization, and what are the kind of the pros and cons of democratizing art?
Yeah, that's very good questions. So in terms of like democratizing art, like I'm not sure if this is really democratizing it. This is, I guess, democratizing simple illustrations. Like I'm not sure if this is making it possible for people to create the artwork they want. Like sure, you get an artwork, but same as a Google search. If I search nice paintings, like it gives me something, but did I create that? I'm not sure about that. And in terms of a push for a realism, like that's one of the things that we're considering. I think mainly the cost saving would probably, for company perspective, is most important. Like these projects takes a lot of hours, but there's also some push for non-photorealistic projects. Like to give you an example, like the Into the Spider-Verse, like they were using machine learning for the contour lines of the 2D ink lines that they were using. And that's not photorealistic, it's just as for the purpose of artistic purposes. And that's what I would prefer to do, but yeah, I think companies just always want to save costs.
Brilliant, thank you.
So my question is on the critic side. You said there's this process where the artists show their artwork to a room of people and get it discussed and this sort of thing. So that's a human critic giving feedback on the art.
Yes.
Is there, like, what's the sort of state of the art in the AI giving feedback on the work of art? Is it like nowhere, or is it starting to happen? Do you see possibilities for that?
Yeah.
Because it's an expensive process, right? Getting the feedback itself, it's a bit of a bottleneck.
Yeah, definitely. That's an interesting question. I haven't really seen much work in that area. I mean, I could be completely wrong. Maybe there is a whole literature there, but it's not something I've seen before. I guess the closest thing I can think of is like the discriminator in adversarial networks that learn to judge if something looks real or not. But I'm not aware of like any work that gives you like detailed feedback about like what looks right. And it's also, a lot of it is subjective as well. It's about the art direction. So like I'm sure there is like stuff like that could be tell you like the reflections look off on that car, like don't look photorealistic, but I'm not sure if you'll ever be able to art direct you, if that makes sense.
Yeah, thanks.
Anyone else? Yeah, sure.
Thank you. Again, hate to parrot, but really great talk. As a really kind of vague question, and I guess this will also be mostly opinion-based, don't yell at me, lots of people in the room, because I know there's quite a few people here who's done machine learning in some form or another. How do you see, like you individually see this sort of machine learning for animation? Like where's your ideal end goal for all of this? Is it, like how much do you want there to be editability? I mean, you said editability is important, but to what extent do you want it to be easier to animate versus have still some human creative input? Did that make sense? I hope that made sense.
Yeah, it did. Yeah, that's a tough question. Like, I'm not sure, like, where is the right way. Like, an animator, like, at Embark, he had an interesting way of describing this. Like, he said, ideally, I would want the Jarvis of animation. But, yeah, me personally, I would like to take this at a stage where animators can be like actors. They focus on the performance and that. Like, they don't focus on the technical aspects of it. They just focus on making a convincing performance.
Thank you.
Anyone else have time for one, probably? Two?
Hi, thanks for the talk. I was wondering, outside of animation, do you have any examples where else in the workflow there are these time sinks that you think could benefit from this kind of thing?
It's all over the place, I think. I mean, for VFX, like, specifically, we have, I think a lot of time gets, like, synced in, like, roto, like, basically, like, you have something in the background that you might want to remove, or you have, like, you want to separate your character from the background. And that's typically someone going frame by frame manually with, like, curves around the character. It's pretty, like, difficult, like, tedious work, I would say. And there's, like, all over the pipeline, like, for games, for VFX, like anywhere you look at, like UVing, roto, like, I think most 3D tasks are probably, like, not exactly necessary for the creative process. It's just the technical aspect that we have to deal with, I guess.